Hi everyone, today is a little question called general parentheses. So given n pairs of parentheses, want to write a function to generate all combinations of well-formed parentheses. So basically well-formed parentheses means all the left parentheses can be closed up by the right parentheses. So you see, if n equal to 3, we have these kind of combinations, which is valid. And when n equals to 1, we only have this combination, which is valid. Okay, now finish the problem description. Next thing you think about how to solve this problem. So let me use graph drawing here to help you understand. As I mentioned before, for this kind of problem, I would prefer the backtracking solution, uh, which is easy to understand and efficient for time capacity and memory usage. In backtracking solution, the first thing to initialize, right? So here we have to initialize all the left parentheses we can use and the right parentheses we can use. Uh, Here, let's say they are both equal to 1 because our n initialized as 1. And we also need a pass variable to restore the parentheses we have used, right? So this variable initializes an empty string. Okay. Now finishing the initialization, next thing is to think about which way to go, alright? So one way to go the left direction, which means we will have use one left parenthesis, so go this way, and use one left parenthesis and get left equal to 0, right? And right still 1. But parenthesis here, I should add by the left parenthesis. Okay, here. Okay. Now, we still have two directions, one go left, one go right. So let's say we further go left, and we have it. Left will be -1, right? And the right will be 1. And parentheses will be added by another left. Oh, sorry, here should be a single one. And to this step found, okay, left is smaller than 0. This means we have already exceeded the limit, right? So I have to return down to finish this pathway. Okay, now finish this pathway since this is a backtracking solution. So I have to go back to the previous level, right? So go back to this level, and then we see what can we get from the right recursion. Okay, so for the right recursion, the left will still be 0, the right will be deducted by 1, so right will be 0. And the path now should be one left parenthesis closed by another right parenthesis. At this step, we found, okay, left is equal to 0 and right equals to 0, right? This means it's a valid answer, so I want to append this path to result. Okay. Now finish appending the path to result. Next thing to check further about the left and right parentheses. So we keep going down. For the left side, well, left equal to -1, right equal to 0. And the parentheses should be like this, right? And we see here the left is smaller than a 0, so it's not valid path. We have to break it out. And if we go right, what happened? We go right, we have left equal to 0, and right is -1, right? And now the parentheses should be look like this. So let me draw it out. And here, since right is smaller than 0, we also have to break out. We now finish the left and right recursion at this level, right? And we have to go back to the previous level. So now we have right at this level. And for this level, still we have finished the left and right recursion, so we have to go back further to the previous step. So now we have right at where we started, so at this level, and we want to check the right side. Okay, so for the right side, the left still 1, the right is not 0, and the parentheses should add it by right parenthesis. But here you see if at right parenthesis at this position, even you have many left parentheses, there's no way to close this up, right? So this means if the left remaining parenthesis is greater than the right remaining parenthesis, we cannot finish this task, and we have also to return null. Okay, so return null for this step, and now finish this and this. This means the recursion at this step is finished, right? So this entire search is done. Okay. And Now the last thing we want to do is to return our result, which is array containing this single element. Now finish the explanation part. Let's dive into coding. Okay, so first, let me write a general framework for backtracking. So again, as we did the previous question, we need empty string and pass the empty array as the result, and also to name the remaining parentheses for left and for right. And let's say that left and right, I initialize n. Okay, now let's call the helper function. So pass in the left and right, and need to pass in the result, right? And finally return the result main function. Now this should main function next thing to run helper function. So let's remain in the helper function in backtrack, so it's more easy to understand. So just pass all these variables here. And the first thing to consider the corner cases, right? If one, the remaining left greater than remaining right, or left and right is smaller than 0, this means we cannot finish, so I have to return none. Otherwise, if we found, okay, left exactly equal to right and exactly equal to 0, this means we have finished this task at this step. So I have to append the path to a result. And otherwise, oh, sorry, just add a comment here. And otherwise, we just run recursion on the left side and right side. So use this backtrack function. And if run on left side, we'll use up one left parenthesis, so left will be left minus 1, and passing right, and path should be added by the left parenthesis right, and result should be the same. And if we run the right parenthesis, so just copy paste here to save time. The left should be as it is, the right should be right minus 1, the path should be added by the right parenthesis. Okay, now finish code, let's submit to see if it works. Okay, you see the time capacity and memory usage of this solution is not bad, right? And I think the code is short and easy to understand. If you like this video, please subscribe to my channel, and see you next time. Thank you.